Let's explore the AWLT model within the Entity Data Model Designer. All right, first thing to notice here is notice how all of the entity object names are singular. So I have customer, I have sales order header. If I scroll down here a bit, I can see address and customer address, which is actually a many-to-many table. I have the sales order detail table, and so forth. And then furthermore, all of the navigation properties are either singular or plural based on the relationship between the entities. So a customer can have multiple customer addresses, and so that's plural, and a single customer can place multiple orders, so the sales order headers is plural. But then if I come down here and look at the sales order header table, I'll make that a little wider too, it's just so you can see all the names a little bit better. Notice that it has both singular and plural navigation properties. An order typically has a couple different addresses associated with it, one for the ship to address and another for the bill to address. And each of those properties can have a single address, and so those are singular. Similarly, only one customer can have placed a particular order, but a single order can have multiple sales order details, and so because that is a one-to-many relationship, that's pluralized. So as you can see, Entity Framework is pretty smart about the singularization or pluralization. Now, sometimes it doesn't get it quite right, particularly in English, because in English we have such weird, well, all kinds of weird grammatical rules anyway, but the pluralization is a little bit weird. Entity Framework understands some of those weirdnesses, but if it does the wrong thing, you can easily correct it and put in the correct term. All right, I'm going to mostly use the customer object for examples. So I'm going to move this view out of the way. It's not connected to anything. All right, so here's the customer entity data object. Each entity has a set of scalar properties, and that's this list right here. And those are listed under the properties header within the entity data object. So this is where the values that are associated or contained within the entity are stored. So customer includes customer ID, title, first name, last name, each of which is going to contain the current value of the corresponding field in the customer table from the database when the object is materialized when you run your application. And then the second part here are the navigation properties that I alluded to. So any entities that have associations with other entities also are going to have one or more navigation properties, depending on the number of objects they're associated with. Customer is associated with two other objects, as you can see from these lines here, and so it has two navigation properties. And you can use those properties in your code in order to access, say, the collection of customer addresses, or the set of sales orders that this customer has placed. The nice thing about these properties is that they let you navigate from a customer to its addresses or orders without having to write a join within a link expression. You can just reference those properties and you have a reference to the collection of that customer's addresses. It really is pretty easy. Now the lines that connect these objects are called associations, and they represent the relationships between the tables in the database and define the relationship between those associated entities. Each end of an association is described by what it's called its multiplicity. So I have a 1 there and I have an asterisk there. This is the number of entities that can be on that end of the association. So this is an association between a customer and that customer's orders. So there can be one customer for each order, but you can have multiple orders for a single customer. So hopefully in any ongoing enterprise, any particular customer is going to place many orders over time. Now, multiplicity is often referred to as cardinality in relational database theory, but Entity Framework more often uses the term multiplicity. So just keep that in mind. They're basically the same thing. So there are three options for the multiplicity of each end of an association. 1, and that's represented by a 1, makes sense. many, which is represented by an asterisk, and then 0 or 1, which is represented by a 0.1. Okay, one quick warning about these association lines before I talk about multiplicity a bit more. The location of these lines has no bearing on the fields that are related to create the association. So this is an association between the sales order header. And if I scroll down here a bit, you can see that there's a customer ID. That's the foreign key in this object that relates to the primary key of this customer table here. But notice that the line is located nowhere near customer ID, and this is coming out of the top of it, and so you can't tell what field. Just keep in mind that you can move these lines around as you want. They don't relate to the fields that they're adjacent to in any way. So I can go ahead and move that down like that. I can move this around. I can do various things. I can make this as complicated as I want. But this location, where it ties into the object, is not related to the fields that create that association. All right, so once you have the multiplicity at each end of the relationship, you can combine them in various ways. So a 1 to a star means 1 to many. And again, for example, a single customer can have many orders. And then star dot star means many to many. Now, an example of this relationship would be customers to addresses, although that's not really the kind of relationship that the AdventureWorks LT database uses. But the idea is that a customer can have many addresses, home, school, work, mailing, and each address can be used by multiple people, such as several family members living at the same home address. And then 0.1 to star, like this relationship here between addresses and sales order header, means 0 or 1 to many. So another example of this is the relationship between product category and product entities. A product category can have many products, and a product can optionally have a category assigned to it. Now, one thing about this object right here. This is a regular entity data object. It relates to a table within the database, so nothing strange there. But this is a many-to-many table. So this is a linking table that allows a one-to-many relationship between customer address and a many-to-one relationship to address. Now, in this particular case, customer address within the database has more than just the primary keys, the foreign keys, of the table that it relates to, customer ID and address ID. It has some additional information, most importantly, the address type. If, on the other hand, you had a many-to-many table within the database that only had the foreign keys to the related entities, no additional information here like the address type, row ID, and modified date, then Entity Framework would not have created this additional entity and instead would have just directly created a many-to-many relationship between these two tables. But the idea here is that the application, if it needs to get access to address type, is going to need an object where that information lives. And less important, row GUID and modified date. But if it didn't need that additional information, it'd be a direct many-to-many relationship. Okay, let's talk about the Entity Data Model object properties. As is typical for objects throughout Visual Studio, you can use the Properties window to set various properties for objects in the designer, ranging from the model as a whole, a very high-level view, to individual entity properties. So the model stores some properties within the XML that defines the model, while others guide how Entity Framework creates objects when you build the project. So the properties are used for a lot of different things within Entity Framework. Okay, so I'm going to click the background of the model outside any entities and come over here to the Properties window. And I'll go ahead and pin that open for the moment. All right, so because the model is selected, these are the properties for AWLT model. That's the name that I gave the model within the wizard. So the model at this level contains a logical group of entities, which are called the entity container. You can use the settings here to determine whether the object context uses lazy loading to populate objects from data within the database, and that's this option right here. And as you can see, it's set to true by default. I haven't changed any of the default values. You can also use the metadata artifact processing option here in order to embed the XML files for the 3 models in the project assembly, which is the default, or in separate files in the output directory. All right, then you can also use the property window with individual entities. So I'm going to select the customer object here. And so this is the entire object, this entity object. Here's where you can change the name of both the entity set name, which is the collection of customers in this case, as well as the name of the individual object. For starters, it doesn't need to be named the same thing as in the table. If there is a better name within the context of your application for a customer, name it that. Maybe client is more appropriate. Still is customer within the database, but you could call that object a client. And therefore you want to change this to clients. And then you can also set whether the entity data object created for this entity is abstract or not, using this abstract property. And you can also set this to indicate that it's derived from another entity, which makes it possible to use this object in an object hierarchy in an inheritance scheme. And then you can also set the access level here to public or internal. All right, now what I'm going to do is select the property of an entity, in this case, first name. So here in the Properties window is where you can change the entity property's name and the data type. And as you can see, the type here is a string. You can also set a default value for this property, as well as indicate whether this is an entity key. This is the equivalent of a primary key in a database table. Somewhat unsurprisingly, customer ID is set to the entity key, but you can change that after the fact. All right, now it can get a little confusing to talk about a property of a property. So this is a scalar property of the customer entity, and this is a property of that property. So because of that confusion, you'll sometimes see the properties of an entity property referred to as attributes. So that would be these values here. Both terms refer to the same thing in any framework. So in this course, I'm generally going to refer to them as properties of a property. Now, the available properties for an entity property, like customer ID, name style, title, first name, and so forth, is partially determined by its data type. So I'm going to come here to company name, and you can see that its type is string, and I have some facets. You can think of a facet as a characteristic. I'm really tempted to call them properties of a property, but that gets a little unwieldy. So Microsoft calls these facets. So I can set various facets of this type because it's a string. But if I were to suddenly decide that a company name should really be an int32, which is nonsensical, of course, but I just want to illustrate this here. I'll come over here and change that value to int32, and you can see that the facets disappear. If there were any facets I could set for an int32, they would appear there, but there aren't any, so that section disappears. All right, and so you can explore different data types. So I come up here to say date time. You can see that there's a facet of precision. And you can explore other data types and see that, for example, decimal has precision and scale. So these facets are specific to the data type of this entity property. Okay, now, all these other ones don't make any sense for a company name, so I'm going to change this back to the default string. All right, you can also change the entity's getter and setters. And this allows you to set the property to be read-only, write-only, as well as make it internal, private, protected, and so forth. And they're public by default. Okay, one last thing about the facets of an entity data objects properties. Entity Framework ignores some of the facets of an entity property at runtime. And for strings, that includes fixed length, max length, and Unicode. So it's not going to prevent you from writing a string that is longer than its max length, for example. All that means is that the runtime isn't going to perform validation based on the settings. But some applications, most notably ASP.NET, can use these properties to provide a user interface that controls what value the user can enter for the property. So depending on how you build the application can automatically see that you've set a max length, which we haven't here, for company name of 50 characters or whatever, and then it'll build the user interface to allow the user to only enter 50 characters. So that's how they're used within an application. And then the facets are also useful when I start talking about model-first design, because they influence the data types that Entity Framework is going to create for those fields within the resulting database table. Okay, so now when you select an entity or an association between entities, as I just did there, the Properties window displays the properties for that association. All right, so this is the association between the customer and the sales order header. And here's the association between customer and the customer addresses. Okay? And so the properties change based on the association that you select, of course. As you can see, the properties list the endpoints of the association. So the navigation property at end 1 is customer addresses, which is right there, and it helpfully underlines it within the entity object. And at the other end, it's customer. So if I scroll down here, you can see that customer is underlined. And it also underlines the key that associates the two objects together, customer ID in this case, in both of the objects. Among other things, you can select the onDelete value for either end of the association, and the options, as you can see here, are None and Cascade. By default, deletes are not going to cascade through the hierarchy, but you can change that value. And if you set it to cascade, when you delete one object, it'll delete the related objects at the other end. You have to be careful with that because it can be a little bit dangerous, but it can really simplify a lot of your coding because Entity Framework takes care of deleting the related objects. All right, so within the Properties window, you can see that the relationship here is one to many, and one multiplicity and n2 multiplicity. But you can change that if you want to. So I have a drop-down list there, and you can select any of the 3 types of multiplicity. And then you can also change various names associated with the association, including things like the names of the navigation properties that let you navigate from one of the entities to the other. In this case, customer addresses in the customer object, or customer within the customer address object. And then you can also change those right directly within the entity object. And then you can also change the association's name and association set name properties. Although, because I created this model from an existing database, the wizard picked up the relationship name from the database, here fk customer address underscore customer underscore customer ID. But you don't have to use that within the model. All right, now this referential constraint property defines the dependency between the two entities when you use foreign keys. So if you click the ellipsis button here, that'll open up the referential constraint dialog box. This defines the entity equivalent of a foreign key relationship, here stating that a customer address entity, which is the dependent entity, must reference a customer entity, which is the principal entity. If you don't use foreign keys in your model, the model would not use referential constraints like this. Each entity's navigation properties are special types of properties that reflect associations rather than simple data types. An entity can have either of 2 types of navigation properties. those that reference single entities, which is called a navigation reference, and those that reference collections of entities, which is a navigation collection. Unlike the scalar properties that contain a simple data type value, navigation properties provide information about how to navigate to a related entity or collection. You can think about the properties within that object, the navigation properties, as holding a reference to something else that is associated with that entity object. Okay, so I can select the customer navigation property here, and there are the properties within the properties window. So the association property here indicates which association this property is tied to, because you can have multiple associations with multiple entities and even the same two entities. And this is where it has the information about how to navigate to the related entity, in this case the customer entity. These from role and to role properties, which are disabled so you can't change them from the properties windows, it gets those from the association, indicates here that you have to navigate from customer address to the customer entity. And once again, this is another place where you can change the multiplicity for this end of the association. And if you do that, the change will be reflected both here and within the association definition. And then the return type property, which is also disabled, so you can't change it, indicates what you can access through the property. And again, this is an instance of the customer object, a single instance. Okay, then if I go to the other end of the association, customer addresses, you can see that this has a many multiplicity, 2 customer addresses. And so this references a collection, multiple customer addresses. And that's what you would expect, because this end of the association has a multiplicity of many. Now, one thing to point out about all this is that if there's only one customer address associated with a particular instance of customer, so this single company with this defined schema has only a single address, you'll still have to work with a collection when you access that customer address. And if a customer has no addresses at all, the customer addresses property, this property right here, will reference an empty collection. And in either case, the collection type is system.data.objects.dataclasses.entity_collection, not an object in the system.collections namespace in the .NET framework, because the entity collection has special features that support everything that entity framework has to do.